The purpose of this video is to show you a little bit about the circuit apparatus you'll be using in the lab tomorrow, the DC Circuits lab, and to give you some background information about how to connect these resistors in series and in parallel. First of all, I'm only showing you a portion of this apparatus. There's more up at the top here. There's a thing with wires here. Be careful, the one end is open, and so students have a tendency to accidentally dump out those wires by kind of tilting it up. You'll see they come out pretty easily. I'll leave them out for now so we don't do that again. Another important thing at the very top, it says kit number. It's actually a kit letter. Make sure you write that down for your lab. That'll be extremely important, so it absolutely needs to be on your lab report. We don't use anything that's over on this side over here, so you don't need to worry about it. If you're creating any diagrams for lab or anything like that, I'm perfectly fine with you leaving that out of your diagram. It's not important here. So we're just going to focus on this portion that has the batteries and really just this section that's down in white here. When you get to your circuit board tomorrow, you will see that there will be 3 resistors already clipped in there. Those are just clipped there as a holding place. You are more than welcome to take them out and look at them, switch them positions, anything like that. They're just there so that we don't end up losing them. So here's one important thing about these circuit boards. You'll notice that at this bottom, in this white section, there are always 2 springs in this little box right here. Each of these 2 springs are electrically connected underneath the circuit board. If I flip the board over, you'll see that in between these springs is this kind of light blue area. That's a wire. It's imprinted on the circuit board, but that means that it's electrically connected. The reason that's important to you is because if I need to plug something in over here, if I want something to be connected to this resistor, I can plug it into either this spring or this one here. It doesn't matter since they're electrically connected. Another very important thing, this was mentioned in the multimeter video, but you need to make sure that there is a small wire connecting the negative of this battery to the positive of this battery, or else you won't have a complete circuit when you connect to these outer springs. Once you have this wire there, you will not do anything else with these middle 2 springs. Everything will be done with these outer springs. It was already shown in the previous video exactly what to do with measuring the resistance on a multimeter, so I'll move on from there. Once you have measured the resistance, you're going to want to put the resistors in a series circuit. You're going to need to pick them up from their current location and move them so that we will create a path the current must go through all 3 of them. There are multiple ways to do this. The most important thing is that once you've already measured the resistance of each one, you remember which resistor is which, because you will be calling them resistors 1, 2, and 3, and so you just need to keep straight which one's 1, which one's 2, and which one's 3. One thing that I can do is arrange them like so, into a path here where they're all connected. Again, remember that these 2 springs are connected and these 2 springs are connected. So then if I wanted to measure the resistance, I would take my multimeter, and as we learned from the multimeter video, if I'm measuring resistance, I put it on the resistance scale. I take my 2 probes, and I'm just going to set my multimeter down right here for now. I would take my 2 probes, put one probe on one end of that circuit, and the other probe on the other end. Again, I can just kind of stick them in there, and you'll notice I don't get a reading just yet. I'll click forward until I do get a reading, making sure to pause in between. And there we go. I get a reading of 0.299. There's an M here, so 0.299 times 10 to the 6th. The next portion we'll be putting these in series, and when we get to the portion where we have to put these in series, we're going to need some wires. Before I get to that, I'm going to show you how to connect this series circuit to the battery. I don't need that multimeter anymore. I'll move that off to the side. And now I'm going to start working with these wires that are here. One end of the circuit needs to connect to the positive side, so I'll put a wire right in here. And the other end needs to connect to the negative side, so I'll put a wire right in the other side. Remember, no other wires go into these middle two springs, just to the outer edges. Now I have a complete circuit, and I can use my multimeter to measure voltage as well as resistance. So I'll do that right now. I'll just set this down here. Everything that you're doing in this lab, you'll set it to 20. This time you need to pay attention to the red and the black leads. If I'm measuring the voltage across the resistor, I'm going to want to put the red near the positive side, and you can determine that by following this positive path. So if I'm measuring it across this resistor on the bottom here, this would be the positive side, that would be the negative side. I'm not getting much of a reading, 0.01, and so to increase the sensitivity of my meter, I'll go down here. I have a very small voltage across this resistor, 0.005. Maybe I'll even go down one more. 5.1, 5 points, jumping around a little bit, so you'll want to just pick the average, whichever you think is the best. The most important thing is that notice that there's a little m in front of this. That means whatever is on my screen gets multiplied by 10 to the negative third. Taking those out, now we got to measure current. Current's different. This is a very important aspect. Current, remember, is the flow of electrons. So for a meter to measure current, electrons need to be flowing through that meter. To force electrons to flow through a meter, we have to make it so that the meter completes the circuit. There's no other path for the electrons to go through except for the meter. That means we need to take out a wire and put the meter in its place. So I'll put one probe in here and one probe in there, and then if I'm measuring current, remember, I need to switch it to that current measurement. I'll start at the smallest, and that smallest is 200 microamps. And I'm going to see if I get something. I don't really get a whole lot, so I'm going to stick with that 200 microamps. Everything else is going to give me 0. And I'm getting 0.1 microamps. Very small current going through there, but that is the current that I have. So again, to measure resistance or voltage, we just go across. We don't have to remove anything. But to measure current, we must remove a wire. That is vitally important to this lab. Next, I'll show you how to set up the circuit in parallel. That one's a little bit different. Again, there are multiple ways to do this. And I'll show you a couple of those different ways. Don't worry too much about writing this down for class time tomorrow. This is actually something that you need to be able to figure out how to do on your own, but I figured it would be a good idea to give you a preview about that. So one way is to create a path. Actually, I'm going to move this all the way down over here just to make it easier on me. I'm going to go from the negative side of my battery to the spring here, and then from the positive side of my battery to the spring on the other side. Now this isn't connected to any of the resistors yet. I have to connect it to the resistors. So I'll put one wire there. I know this one's kind of hard to see. You see where I'm putting it in. It goes outside of the screen here a little bit. There's another one. So between these two and my final one over here. And I'm going to mimic that setup on the other side up here. I will have an example of this circuit set out in class tomorrow so that you can use this to help you create this circuit instead of trying to copy down what you're seeing on this video. I think that would just be a little bit confusing without the board in front of you. Okay, so my circuit is now set up. Let's get some of these wires out of the way so you can actually see here. Okay. So this is now set up in parallel. A couple of comments when you're measuring things. If I'm measuring resistance in parallel, bring my multimeter back into the picture here. I switch to this resistance measurement. I always start on the lowest, and you want to go opposing sides of the circuit. So probably the best way is to put one probe over here. Notice where I am. I'm over on that left corner of the screen, and another here. Those are complete opposite corners of the circuit. Stick that one in there so it stays as I adjust my scale so that I actually get a reading. There we go. Finally a reading. It's jumping around a little bit, but I would say 33.8 seems what it goes back to regularly. So 33.8, but then notice on the scale I'm on the 200K, so 33.8 times 10 to the third ohms would be my resistance. Voltage is measured the same way as it was in series, just going across one resistor at a time. Current, again, remember, you must remove a wire. It's up to you to figure out what wire to remove. I'm going to leave that as something for you, so that there's a little bit for you to figure out with this lab. Again, remember, when you're finished, you must turn the multimeter off so that we do not drain the battery. That's the end of the introduction to this lab. Make sure that you read over your lab handout before class so that when you come to class you are able to take the data quickly and aren't feeling rushed for time. When you do get to class and you're taking your data, go ahead and take all the data first. Don't worry about your calculations. If there's time left at the end of class, you can come back to those calculations. Feel free to email me any questions you may have. Otherwise, I will see you tomorrow.